Movies in the third dimension. They've been around a lot longer than you probably realise. Nowadays, the old movie greats are being remastered into 3D, the new Hollywood blockbusters are exclusively 3D, and even the Queen delivered her Christmas message in 3D. But how much do we know about this technology? Let's take a closer look at the science behind the 3D illusion. So how does 3D occur naturally? Well, our brains interpret depth by combining two slightly different images seen by our left and right eyes. To visualize this, hold your index finger at ruler's length away from your body. Close each eye separately and notice that the two images are slightly different. These probably look familiar. They're called anaglyph glasses, and they're one way of filtering out what each eye sees. For the old school anaglyph glasses to work, you need two images, one red and the other cyan. The red lens blocks the red image and the blue lens blocks the blue image. There's only one problem with anaglyph glasses, and that is making sure that the rest of the colours in your image look right. The solution? Polarization. Invented in 1936, polarized 3D glasses rely on the polarization of light to separate the two images. You've come across Polaroid before, and in Polaroid film are lots and lots of polymer molecules. Molecules that are stretched in a particular direction. To illustrate this, if we put two 3D glasses in front of each other, you can see through one lens, but not the other. Why does it do that? Well, light is an electromagnetic wave. It's an electric field and a magnetic field. Light is propagating in that direction, and the electric field is pointing that way. So what the Polaroid does, is if you align the Polaroid in the direction of the electric field, the light gets through simply. However, if you rotate the Polaroid, the light cannot get through. This means that the light coming from the screen associated with the left eye is polarized horizontally, but the light coming from the screen for the right eye is polarized vertically. Now we have a way of distinguishing between the two images. So you're watching two movies at once, with slightly different scenes, and then you're using the polarization of light coming from the screen to trick your brain into thinking that what I'm seeing here is real, and therefore must have depth. So the next time you see a 3D movie, you'll know how and what you're seeing through those scientific glasses.